Hello everyone. You are on the SuperKit channel. Using many of my own and other people's devices that accumulate electrical energy, time after time I ran into the fact that their connectors, from which I was supposed to get 12 volts, were outputting 13.5 and even almost 14 volts in the case when I agreed to a separate UPS for the router. As luck would have it, among low voltage devices, 12 volts is one of the most demanded voltages. And if a conditional E27 lamp, which is designed for a voltage from 12 to 36 volts, really does not care what voltage from the specified range it receives, then I was definitely worried about my router. After even a special UPS for the router also output an overestimated voltage, I realized that searching for such devices with a voltage of 12 volts is pure roulette. I went to AliExpress in search of a voltage converter in order to end up with guaranteed 12 volts. I already had a similar device, only there it was 12 volts at the input and 19 volts at the output. And I found what I was looking for. It is stated that the case is aluminum. It does not look like pure aluminum, but it is clearly metal, apparently some kind of alloy. For wires come out of the case, 2 for the input and 2 for the output. Different options are sold on AliExpress, but specifically for myself I chose one so that a voltage in the range of 8 to 35 volts could be applied to the input. At the output, there will be 12 volts in any case. And I do not need to switch anything anywhere. I simply apply any voltage from the specified interval and get 12 volts at the output. Be it 9 volts. Or 13.5 volts. Or even 20 volts. Therefore, this is not just a voltage converter, but a kind of stabilizer. Along the way, for more convenient connection and disconnection, I soldered 5521 sockets to the wires coming out of the stabilizer and secured the wires with a cable tie. This allows the construction to be disassembled at any time. Also, another important parameter that determines the load that can be connected is the current. For my devices in total, 2 amps are needed, since with one stroke, through a double splitter, I will connect both the fiber optic modem and the router. The first consumes 0.5 amps of current, and the second 1.5 amps, a total of 2 amps. Naturally, it was necessary to take into account a margin, since I do not want the stabilizer to operate at the limit of its capabilities. And also, what if the connected devices change and it will be necessary to have some extra 0.5 amps? When choosing, I took this into account, so I wanted to order at least 2 times more than I need. By this logic, I came to a value of about 5 amps. But it is also necessary to take into account the fact that the Chinese can, to put it mildly, deceive. As a result, I took 10 amps, since I think that the amps here are Chinese. Perhaps the Chinese even have ohms. And what was indicated here as 10, I considered to be like 5 in reality. Since the power supply will also become insufficient, because each of mine already produced less current than both devices can consume together, I ordered it as well. Again, most likely, the router power supply of 1.5 amps would be enough to cover both the modem and the router, because the total consumed power also shows that in most cases both devices together consume even less than 1 amp, but I decided to purchase a power supply as well. The new power supply is stated to have a voltage of 12 volts and a current of 6 amps. In terms of current, in this case I reasoned in the same way as in the case of the stabilizer. The Chinese definitely overstate this parameter in the specified characteristics, so it can safely be divided by 2. When the power supply is operating, this is indicated by its blue indicator. When there is electricity, I connect the router and modem to the grid, and when there is none, to the charging station. All this is done by switching just one wire. I do not turn off the stabilizer, even when the system is operating from the grid through a power supply that already outputs 12 volts, it is easier for me this way. The U-green charging station shows about 6 to 7 W of consumption, and the difference in operating time is immediately clearly visible, due to the inverter being turned on for connection via 230 volts. The predicted operating time of the router and modem is about 20 hours, and when the connection occurs to the supposedly 12-volt connector, which in fact outputs 13.5 volts, the predicted operating time is about 63 hours. In the case of operation from the capital charging station and the same consumed power, the predicted operating time is difficult to estimate, since the station, even with a remaining charge of 19%, showed a value of 99 hours, which is the maximum for the charging station screen. In fact, it should have shown less, but most likely the consumed power is very small for such a station, and it simply cannot calculate it, although it does see how much the connected devices consume. In any case, when I connected a boiler to it in the cigarette lighter socket, a more or less correct value was displayed. For convenient connection, I purchased many different cables with a 5521 plug. Here 5.5 mm is the outer diameter of the plug, and 2.1 mm is the inner diameter. Long wires of 1 and 2 meters added chaos around the router, and in order to somehow sort it out, I additionally bought short ones of 30 centimeters. I also bought a 5-meter extension cable for the 5521 cable and ran it from the charging station to my network equipment. In order not to duplicate cables by length that would differ on the reverse side by the presence of either a plug or a socket, I bought connectors, which easily allows making an extension from a connecting cable, or combining two cables and getting a longer one. If we talk about cables with built-in power delivery voltage triggers, which will immediately give 12 volts from a power bank or charging station, then one can see the same power consumption. This means that it is possible to solve the problem of continuous operation of network equipment without any UPS for routers at all. There are ordinary power banks with the function of charging them while consumer devices are simultaneously connected, that is, with pass-through charging. For example, such a one can now be seen, ROMOS. Unlike the UPS for the router from the previous video, which output almost 14 volts instead of 12 volts, this power bank, although it costs almost 2 times more, however, it also has a capacity 3 times higher, as well as higher port power. And it also charges faster in time, in just a couple of hours, despite its higher capacity. At the same time, it also has LiFePO for type batteries. So there are alternative solutions, and, as you can see, comparable in price. Of course, I chose a case in which it is necessary to constantly reconnect cables. However, this does not mean that it is impossible to do without reconnect irons. In the end, given that the operation of the router and fiber optic modem without using the inverter, even for a charging station with a capacity slightly above 500 Wh, shows a value that can be called an error, well, it will be necessary to charge the charging station a little more often if you simply keep the internet equipment connected to it all the time. This is not such a big problem. Why all this at all, and why not simply connect to the charging station via 230 volts with the inverter operating? Because if there is no electricity, then the inverter will have to be turned on anyway. Because in my case it is not always necessary to turn on the inverter. There is a tablet, sometimes I use it at home. The lighting issue is also solved and it is possible to do without a charging station. So only the internet is needed, and turning on only it through the inverter of the charging station is not the most reasonable consumption of stored electrical energy. It cannot be said that this is completely free for the whole bunch of wires, extension cords, connectors, the stabilizer and the new power supply. I spent about 1000 UAH on AliExpress, but this is cheaper than the current price of a UPS for a router, and the batteries to which all this is connected I already had anyway. The voltage stabilizer made it possible to connect to almost any low-voltage power source. It can be an ordinary lead-acid battery from a computer UPS, a car battery, or even a battery from a tool. At the same time, my devices will receive stable 12 volts in any case. Although, as you understand, with such a stabilizer, the UPS from the previous video could fit into joint operation with my network equipment. Because in such a setup I would get 12 volts at the output. Links to useful things are in the description. Rate the video, subscribe to the channel, there will definitely be more videos about various devices. If you have questions, you can ask them in the comments, I will try to answer them. Thank you all and see you next time.